Hi, welcome to Learn With Me. I'm Deborah Hanson, and today we're going to look at key terms for AP Psychology 1.3, the neuron and neural firing. So if you haven't already watched the video where I go through all of the CED questions and some information that you need to know for the AP exam, you can watch that one first, or you can do this one first, make your note cards, and then go watch the content, whatever works best for you. So this is going to be just the key terms for the 3 questions from the CED for 1.3. And if at the end of this you really like the video, please hit that like button and subscribe. That really helps me a lot. Thanks. Okay, here we go. Okay, so here we go. Key terms, topic 1.3, the neuron and neural firing for AP Psychology. And this is for the new AP Psychology curriculum from the College Board. Okay, we're going to look through the key terms for the first learning objective, explain how the structure and functions of typical neurons in the central nervous system affect behavior and mental processes. So this one is just the key terms that go along with this unit. If you want the explanation and breakdown of how to answer this question, that's on my other video. Okay, so these are the important key terms that we're going to go through. I'm going to go through a definition, an example, and then you guys can take the notes for your cards. And then at the end, I'm just going to flash the words so that you can try to remember what the definitions and real life examples are. This will help you on AP exam when you have to define or when you have to understand how to apply it to a certain stimulus, okay? Okay, we're going to start with acetylcholine. So acetylcholine is a neurotransmitter in the nervous system that plays a crucial role in muscle contraction and in transmitting messages in the brain related to attention and memory. Example, when you decide to move your hand, acetylcholine is released at the neuromuscular junction, causing your muscles to contract and your hand to move. Additionally, acetylcholine is involved in learning and memory processes in the brain. Action potential. An action potential is a rapid electrical signal that travels along the axon of a neuron, allowing it to transmit information to other neurons, muscles, and glands. An example is when you touch a hot surface, sensory neurons in your skin generate action potentials that travel to your brain, resulting in the perception of pain and triggering a reflex to pull your hand away. Agonist. An agonist is a substance that binds to a receptor and activates it, mimicking the action of a natural occurring neurotransmitter or hormone. Okay, here we go. Example, morphine is an agonist for opioid receptors in the brain, meaning it binds to these receptors and activates them to produce pain-relieving effects similar to those of endorphins, the body's natural painkiller. Okay, next one, antagonist, not to be mistaken with the antagonist that you study in literature class, okay, or English class. Here's the definition for the psychology definition of antagonist. An antagonist is a substance that binds to a receptor but does not activate it, blocking or dampening the action of a naturally occurring neurotransmitter or hormone. Here's an example. Naloxone is an antagonist for opioid receptors. It binds to these receptors without activating them, effectively blocking the effects of opioid drugs like heroin or morphine, and is used to treat opioid overdoses. Axon. An axon is a long, slender projection of a neuron that conducts electrical impulses away from the neuron's cell body towards other neurons, muscles, or glands. Example, in the human body, the sciatic nerve contains axons that extend from the lower back down to the legs and feet, allowing for motor control and sensation in these areas. Dendrites. Dendrites are the branch-like extensions of a neuron that receive signals from other neurons and conduct these signals towards the cell body. For example, in a sensory neuron, dendrites detect external stimuli such as touch or temperature and transmit this information to the cell body for processing. Dopamine. Dopamine is a neurotransmitter that plays a key role in reward, motivation, and the regulation of movement. When you eat your favorite food, dopamine is released in your brain, making you feel pleasure and reinforcing the behavior. Additionally, dopamine is critical for coordinating smooth and controlled movements, and a deficiency in dopamine is associated with Parkinson's disease, which leads to tremors and difficulty with movement. Endorphins. Endorphins are neurotransmitters in the brain that act as natural painkillers and mood elevators. An example, after a vigorous workout, you might experience a runner's high, a feeling of euphoria and reduced pain, which is due to the release of endorphins in your brain. GABA, gamma-aminobutyric acid. GABA is the primary inhibitory transmitter in the brain. The primary inhibitory neurotransmitter in the brain, which helps to reduce neural excitability and promote relaxation. When you take a medicine or medication like Valium, it's a benzodiazepine, by the way, to reduce anxiety, it works by increasing the effects of GABA, leading to a calming effect on the nervous system. Glutamate. Glutamate is the primary stimulative neurotransmitter in the brain, involved in most aspects of normal brain function, including cognition, memory, and learning. An example. When you learn new information or skills, such as studying for a test, glutamate is released to help strengthen the neural connections in your brain, enhancing memory and learning. Inhibitory signals. Inhibitory signals are neural signals that decrease the likelihood of a neuron firing an action potential, thereby reducing neural activity. So an example, so when you're trying to sleep, your brain sends inhibitory signals to calm neural activity and help you relax, making it easier for you to fall asleep. Myelin sheath. The myelin sheath is a fatty layer that covers and insulates axons, speeding up the transmission of electrical impulses along the nerve cells. In the condition of multiple sclerosis, the myelin sheath is damaged, which slows down or disrupts the communication between the brain and the rest of the body, leading to symptoms like muscle weakness and coordination problems. Neuron. A neuron is a nerve cell that transmits information through electrical and chemical signals in the nervous system. When you touch a hot stove, sensory neurons in your skin send a signal to your brain, which processes the information and quickly sends a response through motor neurons to pull your hand away. Neurotransmitters. Neurotransmitters are chemical messengers that transmit signals across a synapse from one neuron to another. Dopamine is a neurotransmitter that plays a key role in reward and pleasure systems in the brain. When you eat your favorite food, dopamine's released, making you feel good. Norepinephrine. Norepinephrine, also known as noradrenaline, is a neurotransmitter and hormone that acts as a chemical messenger in the nervous system. So during stressful situations, norepinephrine is released, triggering your fight or flight response. It increases your heart rate, your blood pressure, and alertness, preparing the body to respond to a perceived threat. Resting potential. Resting potential refers to the electrical charge difference across the membrane of a neuron when it is not actively transmitting signals. For example, when a neuron is at a resting potential, it maintains a negative charge inside relative to the outside, typically around -70 millivolts. This state prepares the neuron to generate and transmit electrical impulses or action potentials when stimulated. Reuptake. Reuptake is the process by which neurotransmitters that have been released into the synaptic cleft are reabsorbed by the presynaptic neuron. So after serotonin is released into the synaptic gap between the neurons, it binds to receptors on the postsynaptic neuron, affecting mood regulation. Once its effects are done, serotonin molecules not bound to the receptors are reabsorbed by the presynaptic neuron through reuptake, which helps regulate serotonin levels in the brain. Synapse. A synapse is a junction between two neurons or between a neuron and an effector cell, where signals are transmitted from one cell to another. When a neuron fires an action potential, it travels down its axon to the axon terminal. At the synapse, neurotransmitters are released from vesicles in the axon terminal into the synaptic cleft. These neurotransmitters then bind to receptors on the postsynaptic nerve, initiating a new electrical signal or influencing the activity of the receiving neuron. Terminal branches. Terminal branches refer to the fine branching extensions at the end of the axon that form synapses with other cells. For example, in the nervous system, terminal branches of neurons extend to various target cells, such as other neurons, muscle fibers, or gland cells. For instance, motor neurons have terminal branches that form neuromuscular junctions with muscle fibers, allowing them to transmit signals that control muscle contraction. Threshold. Threshold refers to the minimum level of stimulation required to trigger a neural response, or neural impulse, action potential in a neuron. So for example, in a sensory neuron responsible for detecting touch, the threshold refers to the specific amount of pressure needed to generate an action potential. If the pressure applied to the skin reaches or exceeds this threshold, the neuron will fire and send signals to the brain, indicating the sensation of touch. Okay, so now we're going to go through just the words all over again. You should have these in your flashcards or at least somewhere in your notebook so that you can say them. So we're going to say them on the screen, and then you can pause and say the definition and an example for each one. Acetylcholine, action potential, agonist, antagonist, axon, dendrites, endorphins, GABA, gamma aminobutyric acid, glutamate, inhibitory signals, myelin sheath, neuron, neurotransmitters, norepinephrine, resting potential, reuptake, synapse, terminal branches, threshold. Okay, so now that was the key terms for 1.3, the two first CED questions. So there's 3 CED questions in this 1.3, and you'll see that on the video where I go through each question and how we break those down. This is the section, the third question of 1.3. It's explain how psychoactive drugs affect behavior and mental processes. And we're going to go through the vocabulary that is sort of more specific to this particular question. So the first key term we're going to look at is addiction. Addiction refers to a complex condition characterized by compulsive drug seeking, use, and dependence despite harmful consequences. So someone who's addicted to nicotine may experience strong cravings for cigarettes. They'll continue smoking despite the health risks and find it even very difficult to quit, even after multiple attempts. This behavior is driven by changes in the brain's reward circuitry, leading to a persistent desire for the substance despite the negative effects on health and well-being. Oops, sorry. Amphetamines. Amphetamines are stimulant drugs that increase the activity of certain neurotransmitters in the brain, particularly dopamine and norepinephrine. They are commonly used to treat conditions like attention deficit hyperactivity disorder, ADHD, and narcolepsy. A person prescribed amphetamines for ADHD may experience improved focus and attention, reduced impulsivity, and increased energy levels. However, misuse or overuse of amphetamines can lead to addiction, insomnia, elevated heart rate, and other serious health risks. Barbiturates. Barbiturates are a class of drugs that act as central nervous system depressants. They provide a wide range of effects from mild sedation to anesthesia, depending on the dose. Barbiturates like phenobarbital were historically used as sedatives and sleep aids. They depress the activity of the central nervous system, leading to relaxation and drowsiness. However, they are now less commonly prescribed due to their high potential for addiction and overdose. Cocaine. Cocaine is a powerful stimulant drug that affects the central nervous system. It is derived from the coca plant and is highly addictive. Cocaine is commonly used illicitly for its stimulating effects, which include increased energy, alertness, and euphoria. However, it also carries significant health risks, such as cardiovascular problems, addiction, and potential overdose. Depressants. Depressants are a category of drugs that slow down the central nervous system activity. They are often used medically to reduce anxiety, promote sleep, or induce relaxation. Alcohol is a well-known depressant that acts on the central nervous system by depressing neural activity, leading to relaxation and decreased inhibitions. Other examples of depressants include benzodiazepines, for example, Valium and Xanax, and barbiturates, for example, phenobarbital, which are prescribed for anxiety and sleep disorders but can also be abused. Ecstasy. Ecstasy is also known as MDMA. It is a synthetic drug that acts as both a stimulant and a hallucinogen. It alters mood and perception and is popular in party and rave settings for euphoric effects. Ecstasy is commonly used recreationally to enhance feelings of pleasure, empathy, and sociability. It increases the release of neurotransmitters such as serotonin, dopamine, and norepinephrine, leading to heightened mood and sensory perception. However, it can also have serious health risks, including dehydration, overheating, and long-term neurocognitive effects. Hallucinogens. Hallucinogens are drugs that alter perception, thoughts, and feelings, often causing hallucinations or profound distortions in sensory perception. LSD is a potent hallucinogen that induces visual and auditory hallucinations, alters moods, and distorts time and perception of reality. It works by affecting serotonin receptors in the brain, leading to profound changes in sensory experiences and consciousness. Methamphetamines. Methamphetamines are stimulant drugs that affect the central nervous system by increasing dopamine levels in the brain. They are highly addictive and can lead to serious health consequences. Methamphetamines, commonly known as meth or crystal meth, is a powerful stimulant that increases alertness, energy, and euphoria. It is often abused for its intense effects on mood and energy levels, but it can cause severe addiction, cardiovascular problems, and neurological damage with prolonged use. Nicotine. Nicotine is a naturally occurring chemical compound found in the tobacco plant. It is a highly addictive stimulant drug that affects the central nervous system. Nicotine is the primary addictive substance in tobacco products such as cigarettes, cigars, and chewing tobacco. When smoked or chewed, nicotine rapidly enters the bloodstream and reaches the brain, where it stimulates the release of neurotransmitters like dopamine, producing feelings of pleasure and reward. Long-term nicotine use can lead to dependence, withdrawal symptoms upon cessation, and increased health risks such as cardiovascular disease and cancer. Opiates. Opiates are also known as opioids. They're a class of drugs that act on the nervous system to relieve pain. They're derived from the opium poppy plant or synthesized to mimic its effects. Morphine and codeine are examples of natural opiates derived from the opium poppy. These drugs are commonly used in medical settings to treat severe pain, such as after surgery or for chronic pain conditions. Opioids like oxycodone or hydrocodone and fentanyl are synthetic opiates that are also used medically for pain relief, but can be very highly addictive. Misuse or abuse of opiates can lead to physical dependence, addiction, and overdose, making them a significant public health concern. Psychoactive drugs. Psychoactive drugs are substances that affect the central nervous system, altering mood, perception, behavior, and consciousness. So here are some examples of psychoactive drugs. First of all, stimulants. Drugs like caffeine, amphetamines, and cocaine that increase alertness and energy levels. Depressants, substances such as alcohol, benzodiazepines like Valium, and barbiturates that slow down brain activity and reduce anxiety. Hallucinogens, drugs like LSD and MDMA that alter perception, mood, and cognitive processes, often causing hallucinations. Opiates or opioids, drugs such as heroin, morphine, and prescription painkillers, for example, oxycodone, that relieve pain and can induce feelings of euphoria. Stimulants. Stimulants are substances that increase activity in the central nervous system, leading to heightened alertness, energy, and attention. For example, caffeine. Found in coffee, tea, and energy drinks, caffeine stimulates the brain and promotes wakefulness. Amphetamines. Drugs like Adderall and Ritalin used to treat attention deficit hyperactivity disorder, ADHD, by increasing focus and reducing impulsivity. Cocaine, a powerful stimulant that elevates mood, increases energy, and enhances alertness, but with a high potential for addiction and adverse health effects. Nicotine, found in tobacco products, nicotine stimulates the release of adrenaline and dopamine, leading to increased heart rate, alertness, and pleasure. Substance use disorder. Substance use disorder, or SUD, refers to a condition where an individual continues to use a substance despite substance-related problems. For example, someone with a substance disorder might exhibit behaviors such as persistent use of that substance, for example, alcohol or smoking or anything like that, even when it causes occupational or health problems, craving or strong desires to use that substance, difficulty controlling or stopping substance use, and withdrawal symptoms when not using the substance. So prioritizing substance use over other responsibilities or activities. THC. THC is the primary psychoactive compound found in cannabis plants, responsible for producing the high or intoxicating effects. When someone smokes marijuana, THC binds to cannabinoid receptors in the brain, altering neurotransmitter release and causing effects such as relaxation, altered senses, and changes in mood. This compound is what gives cannabis its psychoactive properties. Tolerance. Tolerance refers to the body's reduced response to a drug over time, requiring higher doses to achieve the same effect. Someone who regularly consumes caffeine may develop a tolerance, needing more caffeine to feel the same level of alertness they used from the smaller amount. Tolerance can lead to increased drug consumption, which can contribute to dependence and addiction over time. Withdrawal. Withdrawal refers to the physical and psychological symptoms that occur when a person stops using a substance they are dependent on. A person who's been using alcohol heavily for a prolonged period may experience withdrawal symptoms such as tremors, anxiety, nausea, and sweating when they're abruptly stopped drinking. Withdrawal symptoms can vary depending on the substance and the individual's level of dependence. Okay, so now let's go through them one by one again. You've got your flashcards, hopefully, or your notebook, or if you try not to look and just see if you can say the definition and an example of each of the words. Addiction, amphetamines, barbiturates, cocaine, depressants, ecstasy, hallucinogens, methamphetamines, nicotine, opiates, psychoactive drugs, stimulants, substance use disorder, THC, tolerance, withdrawal. And that's all the key terms you're going to need to know for this section 1.3, the neuron and neural firings, and related to the 3 CED questions that are in this particular section of the unit. If you want to know more details about those questions and how to break those down, check out my video 1.3, the neuron and neural firings, where I'm going to go into a little bit more detail about everything. But the key terms are really important to know so that you can use them on test day to apply to the questions, okay? If you found this helpful, please like and subscribe to my channel. I appreciate it a lot, and I will see you next time.